And of course, I cannot remember what the formula for the volume is. It's, I believe, darn it.
The volume for any rectangular solid, whether it's a cube or not, is the dimensions, the three different dimensions multiplied together. So it's base times length times height.
Okay.
Okay. Now a cube, those are all the same. So if we let one side of a cube be x, then x cubed would be equal to 54. Excuse me. Let's go back a moment.
Okay.
What is the volume of a cube whose total surface area is 54?
Oh, okay.
So let's talk surface area for a moment. We know, what's the area of one face of this cube?
Length times width times height?
Well, if we're talking surface area, I just want the surface area of that face there. So that would be x times x.
Okay.
Okay? In other words, the area of any cube or brick is just the area of this face plus the area of this face plus the area of that face. I don't know if you can see my cursor when I point or
yes,
not.
I can.
But the front face, the side face, the top face, the back face, and the area of the cube has 6 identical faces.
Okay.
Each one is x squared. So the total surface area is going to be 6x squared. And they're telling us that that's equal to 54. That's going to allow us to solve for x.
Okay.
What is x equal to?
Let's solve that. It's going to equal 3.
Okay. So now that we know what the side length is,
so the volume,
so what's the volume?
27.
Correct. That's very typical of the kind of problems you're going to see, where they're always two-step problems. They're probably not going to ask you something as basic as, what's the volume of a cube whose side length is 3? That would be a one-step problem.
Right.
But this throws in the second step and it gives you the surface area. That allows you to calculate the side length, and then using that side length, we can calculate the volume. Okay, let's see, number 12.
Okay. Let's see.
I'm sure what you're probably doing at this point is drawing a figure.
Yes.
Okay, good. That's exactly what you're supposed to do. So,
okay.
Okay, so I'm going to make point B. And A is east of B, and it's 25. Hold on. You can do better than that, I know. A lot better. Wow. So here's B, here's A, and B is 12 south of C. So here's C, and this unit is 12, which is 9 kilometers west of D. Well, D has to be somewhere there, since C is west of D, and this dimension is 9. This is 25. So now we basically have a trapezoid whose most of the dimensions we know. How do we solve for dA?
Okay, from A to D.
let's put in another letter here just to define stuff, to talk about it. So in problems like this, the trick is to just start figuring out what we know. At some point, we're going to need to know EA and DE for us to figure out DA.
Okay, and yeah, DE would be 12.
Okay. What is BE?
Let's see, BE, it's actually going to be 9.
Okay. What is EA?
That's going to be 16.
Okay. Now, do you recognize that right triangle?
Yes, it's a 3, 4, 5.
Very good. So this is 20. And recognizing those 3, 4, 5 triangles is big.
Okay.
You'll see a lot of 3, 4, 5 triangles, and if you can save yourself, 20 seconds of not having to do the Pythagorean theorem, then you're in good shape. Although, just speaking, let me give you a couple of Pythagorean or right triangles and ask you to solve for one side.
Okay.
If this side is 6 and this side is 7, what is x?
Let's see.
And tell me how you get, what formula you're going to use.
A squared plus B squared equals C squared.
Okay, that's the fundamental formula, the Pythagorean theorem, but when you're actually solving triangles, you're always solving for one side, not one side squared. So it's actually pretty useful to know these two. In other words, know that C is equal to the square root of A squared plus B squared. And A, if I'm solving for one of the sides, has to be the square root of C squared minus the other side squared. And B is the square root of C squared minus A squared. So I think it's well worth memorizing them in those two formats right there, because it will save you 20 seconds every time you have to solve a right triangle by being able to go directly to this step, rather than starting with C squared equals A squared plus B squared and then algebraically solving this for C or A or B. If you know immediately that if you're solving for the hypotenuse, it's the square root of 6 squared plus 7 squared.
Okay.
If you're solving for a side, then a side is always the square root of the hypotenuse squared minus the other side squared. So I can go directly into both of these without having to first manipulate the Pythagorean theorem.
Got it.
Okay, and it's worth doing. Plus, a lot of people end up getting it wrong by the time they've manipulated the Pythagorean theorem.
Right. Whereas, yeah, this is much
This
simpler.
is direct. Yeah, it just and always remember that the first thing out of your mouth should be square root of. And that's what most people, that's the mistake most people make when they try to solve for it, is they forget the square root. So I make it a habit of telling all my students that the first thing should be square root of, because no matter what you're solving for, whether it's the hypotenuse or one of the sides, the answer is square root of. Okay? You don't necessarily have to remember the other one, because solving for one side is the same as solving for the other. It's just the square root of the hypotenuse squared minus the other side squared.
Okay.
Okay. All right. But we didn't have to do either in this problem. All right. 13. 13 is a bit tricky also. We have an isosceles triangle where each side is 2, but this can be anything. So what are all of the possible areas of that possible triangle. In other words, we could have a triangle like this, or we could have a triangle like that.
In this case, would we want to break it down into a right triangle, two right triangles?
Very good. In other words, I didn't really intentionally mislead you by drawing it like this, but unfortunately when you draw it like this, it's hard to see the solution.
Right.
The better way to draw it is as a right triangle that's isosceles, a 45-degree right triangle, where that's 2 and that's 2. What's the area of this triangle?
Area is going to be, let's see, base times height, 4, 2. Okay, it's going to be 2.
Okay. Now, if we try to envision changing this right angle, the only two scenarios that are different would be one in which we have an obtuse angle, or an acute angle. What's the area of the obtuse one? Is it going to be greater or less than 2?
It's going to be less than 2.
Right, because this vertical height has to necessarily be less than 2. So this triangle, the area is going to be less than 2.
Okay.
How about the acute triangle? In other words, that height there also has to be less than 2.
Right.
So this area also is less than 2. So it would appear that the maximum area we can have is 2. We can't have a bigger area than that.
Okay.
What's the smallest area we can have? I shouldn't have really asked that question. Can we have areas of 0.5, 1, and 1.5?
No.
Well, remember that the area of our obtuse triangle is going to be that height.
Okay.
The area is going to be 1/2 of 2, the base, times whatever that height is. So by making this obtuse angle vary, I can make this height anything I want. I could make it 0.1. So there's really no lower limit on the area.
Okay.
Because the base is always going to be 2. And if I increase this obtuse angle so that I draw a triangle kind of like this, well, this height has gotten smaller.
Right.
So there's no limit as to how small I can make h.
Okay.
Same thing with the acute triangle. If I keep reducing this acute angle here, h gets smaller and smaller and smaller. So I can make the area of either of these triangles as small as I want.
Okay.
And, you know, even though we have to find a perfect h to make it 0.5, I can do that. I can find a perfect h to make it 1.0 and 1.5. So anything less than 2 I can make. Even an odd number like 1.79. I can make a triangle that has an area of 1.79 by manipulating h.
Okay.
Okay? So the answers to this is A, B, C, and D.
Okay.
It's another thing that's different about the GRE over GMAT. is, oddly enough, if you go and get the Kaplan book for GRE, and you get the Kaplan book for GMAT, it uses the identical same questions for the problem solving. No difference. The only difference is GMAT has something called data sufficiencies, whereas GRE has data comparisons. And the data comparisons are where we have to determine whether column A or column B is greater.
Okay.
But the math part is the same. That's why I'm surprised that they allow you to use a calculator.
Yeah, they do.
Yeah.
Yeah, it's really basic, and it's a calculator that's on the computer.
Okay. But even still, that's huge.
Yeah, it is.
Remember, with some of my GMAT students, if you had numbers like that, there's all kinds of tricks as to how to do these calculations where you don't need that. You don't need any of those tricks. If you have the ability to do basic addition, multiplication, and division, then it's going to change everything.
Yeah, and on the GRE, they even say try not to use the calculator.
Well,
that
they probably structure the questions so as to not to really make it that beneficial to use the calculator.
Exactly.
We've had one already today where having the calculator really did help.
Exactly, yep.
That problem about the 10% discount.
Right.
And adding an 8.5% tax. I mean, that was easily done if you knew the right way to set it up, but the easier way to do it was by picking $100 as the price and using your calculator.
Yeah.
So it definitely is going to make a difference on how you approach some of these problems. All right, let's take a look at, boy, this could be tough to do. Hold on a second. Let me... I might have to skip this problem. I'm not sure you can see it accurately enough.
Having a hard time seeing it.
Yeah, let me go past these two graphs, even though that they're not bad questions at all, but let's skip those for now. Maybe I can figure out how to get a better picture of that. I've got a scanner. It's just so much easier to use a cell phone camera.
Yeah.
Plus, you don't break the bindings.
Right.
Biggest problem with a scanner is you kind of damage the book when you go to scan it in. So, all right, let's look at this question here. This is pretty typical. Which of the following expresses the area of a circle in terms of c, its circumference?
Okay. Let's see, that would be... So...
I like to suggest people always start out with the general formulas.
Right. Okay, an area is pi r squared.
What's circumference?
2 pi r.
Okay.
Or pi d.
Right. Let's leave it in 2 pi r. I really don't like pi d as a definition of circumference because everything you need to know about a circle is a function of r.
Okay.
So even having a second variable confuses the issue. So I usually make this my general formula for circumference is 2 pi r rather than what appears to be a simpler pi d. Fact is, we don't ever need to think about d. R is where it's at. Whether you're talking a circle or a sphere, r is the only thing that matters. It's the only variable involved. So how are we going to answer this question? How are we going to answer a as a function of c instead of as a function of r?
Make them equal to each other?
They're not, though. They're not. The
No,
area
no,
is
no.
not the same as circumference, so we can't make it equal to one another.
2 pi r.
However, we can solve for r in this equation right there. What do you get when you solve for r?
I'm sorry, I'm trying to write real quick here too. And
Yeah.
okay, when you solve for r, you end up with c over 2 pi.
Okay, and there's the path we're going to use to answering their question. Now we're going to substitute this into the area equation.
Oh, okay.
So area is equal to r times c over 2 pi squared. So what is that reduced to? In other words, we don't see that answer on the one of the 5 choices, so we're going to have to simplify this.
Right. So it is going to be, let me see.
And this is actually much easier done without your calculator.
Okay, and I'm coming up with c squared over 4 pi.
Beautiful. That's it. That's correct.
Okay.
Yeah, and don't get confused by the pi squared. In other words, just leave it as pi squared.
Okay.
Because one of those, that cancels with that, so you end up
Right.
with that. That's why I said don't use your calculator. If one were tempted to use their calculator, then they would use pi and then square pi and divide it and all kinds of necessary calculations. So, okay, let's look at number 18. Okay, let's see. I'm going to have to give you the other answers. This is a key question regarding triangles. There's one specific rule you need to know about triangles. Regarding their available side lengths. Can I have a triangle, before we get to this question, can I have a triangle whose one side is 9, whose other side is 10, and this side is 30?
Yes.
Actually not.
No.
Look at what happens is if I really stretch this and make that 9 and just put a real big angle in there and make that 10, this length has to be less than 9 plus 10.
Okay, that's right.
Okay, so here's the rule. And this is one of those rules where if you can remember the first half of it, the second half follows. And the rule is any side, any of the 3 sides of a triangle, has to be less than the sum of the other 2, or the opposite, greater than the difference of the other 2. Okay, so what I'm saying is if you can memorize the top part, you can always figure out the bottom part.
Okay.
Because the bottom part is just the opposite. It's the opposite sign, and it's difference instead of sum. Okay? So, in other words, if I told you, okay, here's a triangle whose 2 sides are 9 and 10, could I have a third side of 1?
It's got to be greater than 1.
It's got to be greater than 1. So 1 doesn't work.
No.
So 1 is not a possible. Can I have 11?
Yes.
Okay, and what's the other answers that they give here? Or options, rather. 1, 11, and 21. Can I have 21?
No.
Okay. So the only one of those that works is B, 11. Okay. And let's take a look at this last page real quick. Excuse me, where am I at here? 17, that was 18, correct? Yeah. 19 is what we're looking at here. Okay, let's do 19 and call it a session for now. 19 is very, very typical of the kind of problems you're going to see. And it's not easy whenever you have multiplication and division taking place. It's difficult to formulate it in your head. Not just for me, but most everybody that I know. In other words, if I say to you, okay, I can read X pages per minute, and I'm going to read for 10 minutes, well, you know to multiply X times 10. But if I throw in a division in there, it really becomes difficult to formulate what the expression should look like.
Right.
And that's what's going on here, is that, you know, P pencils cost C cents, so we know that it would be P times C, but now we're going to have to divide it into D, and we've got the conversion from cents to dollars, so we're going to have to divide or multiply something by 100. I'm confused already. Okay? So there's a real easy way to solve these without trying to figure out what that is. Now, some people are better at it than others. I've had students that are actually pretty good at taking this information and putting it directly into an expression. It's just I'm not very good at it. So if I came across this problem in a test, I would pick numbers. Because I know if I pick some numbers, I'm going to be able to figure out the answer. In other words, if I say 10 pencils, P is 10, C is going to be 2 cents each. How many pencils can be bought for $3? D is $3. You can figure out that in your head, I'll bet.
Actually, I'm sitting here staring at it at the moment. Let's see. So if I bought 10 pencils at 2 cents each, it's going to be 20 cents. How many can you buy for $3? It'd be actually 15.
Let's make it easier. Let's make D 1. In other words, I can make up any number I want. The numbers I make up, I want to make the math easy. That's why I made P of 10, C of 2 cents. So,
5.
So how many pencils can be bought for D dollars?
5.
Well, if pencils cost 2 cents each, and you have $1, how many can you get?
Oh, what am I doing wrong here? Okay.
50. In other words, to figure out how many I can buy for $1, I merely need to divide D by C. 2 cents goes into 100 cents 50 times.
Right, okay.
Well, I know I can buy 50 pencils with these numbers. So what I have to figure out is, using these 3 numbers, which of these answers is equal to 50? Clearly, A is 2 times 1 times 10. A is 20. Remember, C, D, and P are all whole numbers. C is 2, not 0.02.
Okay.
Okay, so clearly if I take three whole numbers and multiply it by 100, I'm not going to get 50 either.
No.
C has potential. D times P, well, D times P is 10 divided by 200. That doesn't give me 50. Let's try answer D. 2 times 1, so I have 200 in the numerator divided by 10. That gives me 20. That doesn't give me 50. And finally, D times P is 1,000 divided by 2 gives me 500. I did something wrong. No more answers there. Ah, I see what I did wrong. I was wondering why they put a P in here, because P didn't seem to make any difference. I apologize. I've misinterpreted this problem from the get-go. If P pencils cost C cents total, in other words, if 10 pencils cost 2 cents, if I would have read the problem correctly, I wouldn't have made C equal 2. I would have made it equal 20.
Okay.
So that the cost per pencil was 2 cents per pencil. Let me start over. I apologize.
That's okay.
This was horrible. I should have realized when I figured out how many could be bought for D dollars and I didn't use P in the equation that I was doing something wrong. So 10 pencils can be bought for 20 cents.
Okay.
So now we know it's 2 cents per pencil. So if I let D be $1, I know that the answer has to be 50 pencils. In other words, $1 would buy 50 pencils if each pencil cost 2 cents.
Got it.
So I really have to plug in these 3 numbers into these 5 equations to figure out what's equal to 50, and you'll notice that this last one does work.
Okay.
Because 1,000 divided by 20 is equal to 50.
Got it.
Okay, so as long as I didn't want to pick C of 2 cents because then each pencil would cost 1/5 of a cent, and it makes the math much harder. So when I finally realized what the problem was, I went back and made C be a multiple of 10.
Oh, okay.
So that I could figure out my cost per pencil. And I wouldn't want to make it 30. Notice if I made it 30, now I got 3 cents per pencil, and now I got to divide $1 by 3, which doesn't go conveniently. So when you're using this solution of picking numbers, part of the trick is picking numbers that make the math easy. And know that you're going to have to solve each of these 5 expressions using the numbers you pick. So we don't want really big numbers if necessary. We don't want fractional numbers. We want numbers where the math's all going to be relatively easy.
Okay.
All right. Why don't we stop there?
Okay.
And would you like me to bring up my calendar here? Do you know when you want another session?
Yeah, why don't you bring it up and
Okay, we'll have a look here. My week is not too bad this week, and it gets better the next week. Let's see. This is Tuesday. So everywhere you see a white square, I don't have that spot open. So in other words, Wednesday morning works good. 8 o'clock Wednesday night would be fine. Friday, anytime up until 5:30 in the afternoon works, up until 5. Even Saturday and Sunday have quite a bit of openings.
How about Friday at 9?
Okay. Sounds good. Let me put it in here. It's probably easier for me to do it than for you, since I can do it in one quick step.
Okay.
Okay. I will, what I'll do Friday morning rather than call you is I will just text you the meeting ID number.
Okay.
Now, for you to get out of today's session, just click on the X in the upper right hand of that control panel.
Okay.
And to start a session on Friday morning, you'll have an icon on your desktop that looks like this thing here, the GoToMeeting flower.
Oh, okay.
Come Friday morning, just double click on that, and the first thing it asks for is the meeting ID number. In other words, you don't have to go back to that website and re-download it each time.
Okay, great.
Okay, so I don't call the second time, and in fact your audio settings will already be set, so there's nothing you'll have to do other than put in that meeting ID number, and I'll just text that to you.
Okay.
Okay?
That sounds great.
Okay, Angela. I will talk to you Friday morning.
Okay, thank you for your help.
You're welcome. Bye-bye.
Bye-bye.